Hey everybody, this is Miss Berry. In this video, we are going to go over section 2.1. So we're starting chapter 2 today. Chapter 2 is called Equations and Inequalities in Two Variables. And section 2.1 is specifically about the Cartesian coordinate system. You probably already know a lot of this information. And so some of this may be review for you. All right, so we're going to start off with just some terms that you should know. And as I talk about these terms, I'm going to go down here to this graph and just draw on the graph to represent those terms. So we're going to start off with an ordered pair. So an ordered pair, say x, y. This is represents a point on the graph. The order is important here. So x represents the first coordinate. So x represents the first coordinate, and y represents the second coordinate. And really, you could use any variable here to represent these first and second coordinates, but you're probably used to seeing x and y here. Next is the Cartesian coordinate system. The Cartesian coordinate system is named after René Descartes, so that's where the C-A-R-T-E comes from. And the Cartesian coordinate system just refers to this graph here where we have the horizontal axis and the vertical axis. The axis here is you see it represented as this bolded line here. We typically refer to this horizontal axis as the x-axis. And the vertical axis we typically refer to as the y-axis. But again, you could use any variables here. Just depends on your problem. All right, so we have a vertical and a horizontal axis. Then the origin, that's the center point, is the ordered pair 0, 0. So here's the origin right here. Let's use a different color. So that's the origin. The origin is called the origin because whenever you go to plot an ordered pair, this is where you start. So it's like where the point originates from. So that's where the word origin comes from. And then last, we have quadrants. So you can see this Cartesian coordinate system, also sometimes called a Cartesian plane, is split up into 4 parts. That's where the quad comes from. And this is how we label these quadrants. So this is called quadrant 1. And we use, Roman numerals to describe the quadrant. So this is quadrant 1. Then we are going counterclockwise here. This would be quadrant 2. Then down here we have quadrant 3. And then last we have quadrant 4. So you may have a problem where they ask you to plot an ordered pair, and then they'll ask you what quadrant does that ordered pair lie in, or what axis does that coordinate pair lie on. All right, so I'm just going to do a really simple example here. Let's say that I want to plot the ordered pair. Let's do -3, 2. All right, so this is my first coordinate. This is my x. So 3 is my x, 2 is my y. All right, so then I know that x is the horizontal axis, so I'm going to go in the horizontal direction, in the negative direction here. So I'm going to go left 1, 2, 3, and then I have a positive 2 for my y value, so I'm going to go up 2. So this would be the ordered pair, or the plot of the ordered pair -3, 2. All right, so that's just some terms to know. When they say plot, that just means to graph that point. All right, so we're going to start off with a pretty simple example. It says, let's number this. This is number 1. All right, so it says, plot the following ordered pairs on the Cartesian plane. This is the Cartesian plane, also known as the Cartesian coordinate system, and identify the quadrant they lie in, or which axis they lie on. All right, so let's use a different color for each one of these. We'll start with a light blue for 2, 3. All right, so again, this is an X and our Y. So we're going to go in the positive direction 2 units, so that's 1, 2. And we're going up 3. So 1, 2, 3. All right, so there's the ordered pair 2, 3. We can go ahead and write out to the side. You can label these 2, 3. And remember how I designated the quadrants earlier? This was quadrant 1, this is quadrant 2, quadrant 3, and then quadrant 4. Again, that's IV, the Roman numeral. IV represents the number 4. All right, so this point would be in quadrant 1. All right, next we have the ordered pair -5, 0. So let's pick a different color here. So this is our X, this is our Y. All right, so -5, so we're going in the negative direction 5 units. So 1, 2, 3, 4, 5. And our Y value is 0, so we don't need to move at all. So we're just staying on that X axis. All right, so this is the ordered pair. Let me use my thinner pencil here. All right, so that's the ordered pair -5, 0. And this is not in a quadrant because it's on an axis. So we would say this is on the X axis. All right, next we have the ordered pair -6, 6. All right, let's use green. So XY. All right, so we're going to go in the negative direction 6 units. So we're starting off on the horizontal axis. 1, 2, 3, 4, 5, 6. And then again, it says our Y value is -6, so we're going to go down 6. So positive numbers, you go up. Negative numbers, you go down when you're referring to the second coordinate or the Y coordinate. So we're going down 6. 1, 2, 3, 4, 5, 6. All right, so that's the ordered pair -6, -6. And what quadrant is that one in? It's in quadrant 3, right? All right, so that one's in quadrant 3. That was really sloppy. Let's see if I can write that neater. Quadrant 3. Yeah, that's better. All right, and then our last ordered pair, we'll use red. X, Y. All right, so we have 1, -3. All right, so we're going in the positive direction 1 unit on our horizontal axis, so over 1. And then should we go up or down 3 here? We should go down 3, right? Because it's a -3. So we're going to go down 1, 2, 3. And there is our last ordered pair, 1, -3. And what quadrant is it in? It is in quadrant 4. It's going to be important that you remember that you have these quadrants memorized. You're going to have to use this when you get to trig also, so it's a good idea just to go ahead and have them memorized. All right, let's look at the next example. All right, so let's look at this one. This is number 2. For the following equation, determine the values of the missing entries. Reduce all fractions to lowest terms. Okay, so our answers may be in the form of a fraction. All right, so it says, here's our equation, 12x minus 10y equals 18. This is called standard form. So standard form is where you have the x and the y variable on the same side. Or you could just say both of your variables. It doesn't necessarily have to be x and y. It could be like a and b or s and t. All right, but it's called standard form when you have both of your variables on the same side. All right, so 12x minus 10y equals 18. And it says, note, each column in the table represents an ordered pair. If multiple solutions exist, you only need to identify one. All right, so here's our table. We've got some values that are already filled in. So for the first column here, it tells us that our y value should be 0. All right, so let's go over here to the side. This is just going to be a lot of little scratch work. So we're going to take our equation, and for y, we're going to plug in the value 0. All right, so I'm just drawing it in little parentheses there. If you prefer, you could just do a little dot. So 10 times 0 equals 18. It's just whatever your preference is, however you prefer to write the multiplication. You probably don't want to use the little x here since we already are using the variable x. So I would say either a dot or a parentheses. All right, so we have 12x minus 10 times 0. 10 times 0 is 0. So that's really like 12x minus 0. And we know that 12x minus 0 is just 12x. All right, so I wrote that extra step in there. You could probably do that part in your head. All right, so now we're just getting x by itself. So go ahead and divide both sides by 12. Whoops. The 12s cancel on the left-hand side. All right, and we're left with x equals 18 over 12. So let's see. What goes into both those? 6 goes into both of those. So that would be 3 over 2. Perfect. So there we go. There's our fraction in lowest. Remember they told us to reduce the fraction to the lowest term. You could definitely do this on your calculator, but this one was pretty easy. We could do it in our head. All right, so we're just going to repeat this process this time in our second column here. So we're looking right here. Whoa, that was like way off. We're looking right here. This time we're going to replace x with 0, and we're going to see what we get for our y value. All right, so let's see. So 12 times 0 minus 10y equals 18. All right, 12 times 0 is 0, so that part cancels or just goes away. We'll just do a little get rid of that. So we have negative 10y equals 18. Go ahead and divide both sides by 10. Oh, excuse me, we're actually dividing by negative 10, right? To get y by itself. All right, so the negative 10s cancel on the left. And you're left with y equals 18 over negative 10. Let's see what goes into both of those. 2. So that would reduce to 9 over negative 5. I'm just going to put the little negative out front. So negative 9 over 5. Negative 9 over 5. It wouldn't be incorrect to put the negative down here with the 5. It doesn't matter. You can put the negative in the top. You can put it in the bottom. You could put it just off to the side, kind of like how I have, as long as the negative's in there somewhere. All right, let's scoot this way. All right, now we're going to work on these last two columns. All right, so in our next column here, it says replace the x value with 3. I know this is probably really simple, and you could probably do this on your own, but we'll go ahead and finish this table. We might skip some in this next one. All right, so 12 times 3 is 36, minus 10y equals 18. All right, solving for y here. So go ahead and subtract 36 from both sides. It's going to cancel on the left. Leaves you with negative 10y equals negative 18. Divide both sides by negative 10. And we just reduced that fraction over there. So we already know. This time it's going to be positive, right? Because a negative divided by a negative is a positive. And we know that 18 over 10 reduces to 9 over 5. Okay. And let's see. I'm running out of room to do my scratch work over here. Let's see. Scoot it this way this time. We'll do it all over here on the far side. Hopefully your scratch work looks a little bit neater than mine. All right, last column here says replace the y with 2. All right, so again, 12x minus 10 times 2 equals 18. All right, so 12x minus 20 equals 18. Go ahead and add 20 to both sides. Cancels out on the left. We're left with, not negative, sorry, just 12x equals 18 plus 20 is 38. Divide both sides by 12. Oh gosh, I don't know if I can reduce that one in my head. I got my calculator right here somewhere. All right, just to be safe, I'm reducing this on my calculator. 38 divided by 12. Remember on the calculator how you convert it to, if you're using a Texas Instruments calculator, how you convert it to a simplified fraction is you hit the math button, and then the first option says, it has a little arrow and it says frac. That means convert it to a fraction. All right, so that reduces to 19 over 6. All right, let me try that again with the black. All right, so x is 19 over 6. Perfect. And there's our completed table. All right, so this should be pretty easy on the homework. It may be a little bit tedious, a lot of plugging in numbers, but this is going to give you plenty of practice with just doing, simple arithmetic, which is really where a lot of the errors occur in college algebra. All right, so let's look at the next one. Again, we might just do a couple of columns here just to save us some time. We'll do one of the x's and one of the y's. All right, so we have, again, same directions. This is number 3. For the following equation, determine the values of the missing entries. Reduce all fractions to lowest terms. Note, each column in the table represents an ordered pair. So this is representing an ordered pair, which you could then go on to graph. This would be a way that you could graph the equation. So each column in the table represents an ordered pair. If multiple solutions exist, you only need to identify one. All right, so let's pick one of the y values. So let's use 1. All right, so we have 1 equals x squared minus 6x plus 9. We need to move that 1 over. We would like everything to be on one side here since we have more than one term that has a variable in it. So you would like everything to be on one side. So go ahead and cancel that out on the left. Get this thing equal to 0. So combining like terms, we get x squared minus 6x, and then we're going to do 9 minus 1 is a positive 8. And now, let's just take a little sticky note here, and we're just going to cover this up. If I can get this to work right. All right, so we're just looking at just this right-hand side. So just kind of ignore that equal to 0 for a second. This is a trinomial. We know how to factor these. This is a pretty easy one to factor. As you know, if it had a leading coefficient other than 1, we would have to do that AC method. But here, nice and simple. Here we're just looking for factors of 8, so things that multiply to give you 8, that would add to give you negative 6. You may be able to identify these in your head, but if you can't, I'll draw this little table to help you out. Remember how this little table goes. On the left, it's pairs of factors, and then on the right, it's sums of factors. All right, so factors of 8, you could do 1 and 8, negative 1 and negative 8, negative 4 and sorry, that's right. Negative 1 times negative 8 would give you positive 8. All right, so you could do negative 4, negative 2, or positive 4, positive 2. All right, so let's add those together. 1 plus 8 is 9, definitely not giving us the middle term. That's negative 9, again, definitely not the middle term. Negative 4 minus 2 gives you negative 6. So those are our factors. And as you know, hopefully you remember, whenever you are factoring these pretty easy trinomials where you just have a leading coefficient of 1, you can now jump straight to the answer. So draw your two little sets of parentheses. Variable goes first. Here it's x. Then your factors go second. So negative 4 and negative 2. Remember, it does not matter the order that you write them in. You could put the minus 2 first. You could put the minus 4 second. It does not matter. All right, so let's go ahead and move that or delete that sticky note. And now we've factored the right-hand side. Super easy from here. All we have to do is just split these little guys up, set them each equal to 0. And it says if multiple solutions exist, we just need to identify one. So you could pick either one here. So if you add 4 to both sides, that gives you x equals 4. And over here, you get x equals 2. So just pick one of those. Either one will work. Just going to put 4 there. All right. Let's move this back over a little bit. And then we'll do one where we're given the x value. Let's do this one of 0. That one looks like it'd be nice and easy. All right, so if we plug in an x value of 0, we get y equals 0 squared minus 6 times 0 plus 9. All right, 0 squared is just 0. Negative 6 times 0 is 0. So the first two terms cancel out. Those are just 0. So we're left with y equals 9. So that goes there. All right, and then you could continue to repeat this process and fill out the rest of the table. I feel confident that you guys could do this on your own and that you probably don't want to sit here and listen to me work them all out for you. But if you have any questions about these type of problems and you would like to see me work out another one, just let me know and I can make you a quick little video. All right, we have two formulas that we have to cover. And then we will be done. The first formula is the distance formula. This is something you would want to write on your index card. So you may want to take a second, pause the video, and go ahead and write this distance formula down. So it says the distance between 2 points, x1 and y1, and then the ordered pair x2, y2, in the Cartesian plane is given by this formula. So it says d equals the square root, d representing distance. So d equals the square root of x sub 2 minus x sub 1 all squared plus y sub 2 minus y sub 1 all squared. This formula is derived from the Pythagorean theorem. And one very important point about this formula, since it does represent a distance, your answer should always be positive. All right, so answer will always be positive. So distances are always represented by positive numbers. All right, so let's look at this example. I think we're on number 4 now. It says consider the following pair of points, 1, -5 and 2, -9. Find the distance between the points. All right, so find the distance between the points. All right, so we're going to go ahead and label your points. I'm just going to pick x1, y1 for my first one, x2, y2 for my second point. Then let's write down the distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now you're going to plug in your numbers. So d equals the square root of, let's see, x sub 2, that's 2. So 2 minus 1 squared. Again, x sub 2 was here, x sub 1 is here. Plus y2 minus y1. So -9 minus -5. Got to be careful there. All squared All right. Now you're going to plug this into your calculator. I'm going to see if I can get I have a little TI-83 on my computer. Let me see if I can get it to pull up. You can download this too. It's called Wabbit EMU. Oh, come on. Oh. Yeah, I don't remember where I put it. All right, we'll type this in on an online calculator. So let's go to Wolfram Alpha. Wolfram Alpha is just an online calculator. And we're going to type this in. So let's just check. I'm just going to type in what's inside of the radical. So 2 minus 1 squared plus -9 minus -5 squared. All right, so that's 17. All right, so inside here all simplifies to 17. Remember, the inside of the radical is called the radicand. So that equals the square root of 17. Last thing you would have to do is just make sure that this radical is simplified. They don't want you to write this as a decimal. They want you to leave it as a simplified radical. All right, so the last thing you want to do is just look at the number inside your radicand here, or inside your radical. The number inside the radical is called the radicand. All right, so you look at the number 17 and you think, okay, are there any factors of 17, one of which is a perfect square? There aren't here. 17 is a prime number, so you don't have to worry about simplifying this any further. And you're just going to use the positive answer here. Remember, distance should always be positive. If you end up with a negative number, you know you did something wrong. Let's look at our next one. All right, I picked this next one. This is on the homework. I thought it was kind of an interesting problem. It gives you some information, and you kind of have to work backwards. All right, so let's look at it. It says, given these 2 points, 14, 9, and x, 6, excuse me, x, -6, find all such x such that the distance between these 2 points is 17. Separate multiple answers with a comma. All right, so let's write the distance formula. You could go ahead and label your points before you wrote this down if you wanted to. Okay. All right, so label your points x1, y1, x2, y2. I'm just doing that randomly. You could have picked this first one to be x2, y2, and this one to be x1, y1. It doesn't matter. All right, and it told us that the distance is 17. So D is getting replaced by 17. Then we have a square root. All right, then we have x2 minus x1. So x minus 14 squared plus y2 minus y1. So that's -6 minus 9 all squared